Hey, this is Robert Naini, your spray foam advisor, and today we're going to share some guidance on the proper design and installation of hybrid systems in northern climates. Last week we talked about southern climates, and this week we're going to focus on northern climates. These concepts are based on guidelines developed by SPFA, published in SPFA 147, using a series of hygrothermal analysis completed by a consultant assuming several different failure criteria. We're going to focus on the design of hybrid insulation systems within the building envelope with the intent to target code required R values and minimize the potential for condensation and air leakage. Now, as previously discussed and generally understood, a hybrid insulation system uses a thinner layer of spray foam to reduce air leakage and provide a portion of the total R value, and then adds fibrous insulation to provide additional R value. Generally, the SPF is installed in the cavity first, against the exterior sheathing, and the balance of the cavity is filled with another type of insulation, which could be fiberglass batt, blown-in fiberglass, rock wool, wet spray cellulose, dense packed cellulose, another type of spray foam, or reflective insulation. When using hybrid insulation systems, we will generally be concerned with the climate zone because different climate zones require different approaches to designing these hybrid systems. The R value, specifically the total code required R value, and the minimum SPF R value for condensation control based on climate zone. And finally, the interior humidity and temperature conditions. The biggest risk with hybrid systems is the potential for condensation. We must start our assumptions somewhere, so we typically begin with typical operating conditions for residential homes. Unusual occupancies with higher relative humidity, larger temperature differentials, or special designs like pool areas or cold rooms will require additional analysis. When designing hybrid wall applications in climate zones 4 through 7, one key distinction is whether we need to add a vapor retarder on the interior side of all of the insulation. For example, if you are using an open cell SPF as an air seal and insulation in combination with vapor permeable insulation, a class 2 vapor retarder should be used on the interior side of all of the insulation in climate zones 4 through 7. In this scenario, we would install the greater of 2-inch minimum open cell spray foam, the minimum thickness to qualify as an air impermeable insulation, or the minimum recommended application thickness of the product. We want to fill the remainder of the cavity with additional insulation and install a class 2 vapor retarder on the inside surface of the wall. This same method would also apply when we use closed cell SPF at a thickness that does not achieve a less than 1 perm vapor retarder. For example, if we only install 1 inch of closed cell foam for the air barrier qualities, then fill the cavity with additional insulation, we would also need to install a vapor retarder on the inside of all of the insulation or on the interior of the wall. Now, we can also create hybrid designs with closed cell SPF where the use of an additional interior vapor retarder is not necessary. By following this table, we can quickly determine the minimum SPF R value compared to the total installed R value needed to minimize the risk of condensation based on the ratio of SPF R value compared to total insulation R value. Overall, there are several key factors that determine the minimum recommended design thickness for hybrid applications. In climate zones 4 through 7, the design thickness can be determined by identifying the greater of the minimum thickness to qualify as an air impermeable insulation, the minimum recommended application thickness, the minimum thickness to qualify as a less than 1 perm vapor retarder, or the percentage of total installed R value for the specific climate zone. Let's look at an example of a hybrid application in climate zone 5A like Albany, New York, with an R20 wall requirement. Upon discussion with your SPF supplier, you discover that their closed cell foam has been tested as an air impermeable insulation at 1 inch thick, has a minimum recommended thickness per pass of 3/4 of an inch, achieves 1 perm at 2 inches thick, and 40% of the required R20 value is R8, which would be about 1 1/4 inch of their closed cell foam. By reviewing this table, you can quickly see the greatest of these thicknesses is 2 inches. In this part of the country, most walls are 2x6 wood studs, which gives us a cavity space of approximately 5.5 inches. So we can easily apply 2 inches of this closed cell foam in this cavity and fill the remainder of the cavity with another type of insulation and have little risk of condensation in this climate zone without having to worry about adding an additional interior vapor retarder. While this is a standard way to approach a hybrid insulation application, as with any application, make sure that the path you are taking meets local building code requirements. Additionally, remember that the minimum recommended design thickness is going to be dependent on the specific products that you are working with. So consult your supplier and review their technical documents to answer the questions previously discussed to make sure you are using the right thickness of your products for this application. This has been Robert Naini with Spray Foam Advisor. Thanks for checking us out. Catch us on some more videos.